reality setting in for millions of American students, their teachers, and their parents with the outbreak of coronavirus. Schools forced to close, and that means coming up with alternatives. Now for many school kids and their teachers, the classroom is out and online learning is in. Here's CNN's Evan McMorris Santora.
Welcome to another Theory Thursdays with your favorite tutors at GetThere. Nations around the world have closed schools pretty much across the board with the recent outbreak of the novel coronavirus. This is, without a doubt, an unprecedented period in most of our lifetimes. At GetThere, we're still committed to providing first-class educational support to you, and so we're proud to give you our first Theory Thursday episode from our online platform, the same platform we use in our top-of-the-line tutoring service. For our first online delivered episode, we thought we'd keep things real and relevant. Our topic today is exponential growth. Exponential growth is everywhere and can be seen firsthand in many ways, from biological reproduction to accounting and finances, and of course, for today's episode, to the spread of diseases. Let's say that Al has a contagious disease and meets one new person every day. On day 1, Al infects Bert. Now there are 2 people with the disease. On day 2, Al and Bert each infect one new person. On day 3, the 4 infected infect 4 new people, and the cycle continues. When we look at the total number of people infected on each day, we see a pattern start to emerge. Each day's number is just double the previous days. In other words, the number of people infected is just 2 to the power of whatever day it is. The result is an exponential equation, y equals 2 to the x. In general, an exponential equation can be written as y equals a to the x, where a is just some number greater than 1. Notice that the x lies in the exponent. That's what makes it an exponential equation. Notice as well that y equals x squared is not an exponential equation. That's because the x is not in the exponent. When you graph an exponential function, it pretty much looks like this. And you can notice some key features. First of all, the function crosses the y-axis at y equals 1. That's because any number raised to the power of 0 equals 1. Secondly, the function never touches y equals 0, but it gets very close. That's because any number raised to a negative power is always a fraction, which is still bigger than 0. Lastly, and most importantly, we can see that exponential functions grow really, really fast. This rapid exponential growth is why it's so important to follow protocol. Stay indoors as much as possible and wash your hands regularly. In order to stop the exponential spread of the disease, prevention is key. Thanks again for tuning in to Theory Thursdays. We hope that you stay informed, stay safe, and no matter what, you make sure you get there.